Hey, welcome. Today we're diving deep into something that's totally shaking up the building industry, digital fabrication. We're using Chapter 10 of Construction 4.0 as our roadmap to see how we're shifting from old-school building sites to something that looks a lot more like a high-tech assembly line. And believe me, this changes everything.
So let's start with a big question. Just imagine for a second, what if we could essentially print our buildings? Not just build them, but create them directly from a digital file, with perfect, repeatable accuracy every single time. What would that even look like? Well, that is the huge idea right at the heart of digital fabrication.
Okay, so what are we actually talking about here? At its core, digital fabrication is all about creating this perfect, seamless link between a digital design on a computer and a real physical object. It's like a direct phone line from the model to the machine that's cutting, shaping, or printing the part. There's no room for misinterpretation or human error. It's pure data made real.
Now, an idea this big didn't just pop up out of nowhere. It's actually been evolving for a while. It started out as a clever solution for one very specific kind of niche problem, but it's since ballooned to cover the entire construction process. Let's take a quick look at how it's grown up over the last 20 years or so.
So back in the early 2000s, this was all about making these wild, complex architectural shapes, the kind of stuff that was just impossible to build by hand. Then, by the middle of the decade, the focus shifted. It became about how to efficiently produce tons of unique individual parts for a project. But today it's the whole shebang. We're talking about orchestrating the entire workflow, from making the parts, to getting them to the site, to assembling them perfectly. It's about logistics. And that brings us to this really powerful concept called the digital thread. Just picture it, one single unbroken strand of data that flows all the way from the architect's first sketch, through the engineering, straight to the fabrication machines, and right onto the assembly instructions on site. It's a continuous loop of information. That seamless connection, well, that's pretty much the holy grail everyone in the industry is chasing.
So if you want to see where this is all headed, you have to look at the research labs, right? The places that are really pushing the envelope. And honestly, there's no better example out there than the DFAB house. This project is quite literally a working laboratory for the future of construction.
Take a look at this. Now, this isn't some futuristic render. This is a real building that exists right now in Switzerland. And this image shows you exactly what we mean by integration. Every single layer you see here, the walls, the timber frame, the ceiling, was created using a different, cutting-edge digital fabrication method. It's a masterpiece of different technologies all playing together nicely.
What the DFAB house really proves is that these incredible technologies are ready to come out of the lab and into the real world. I mean, it pulled together robotic arms assembling timber frames and 3D printed formwork for concrete all under one roof. And it showed that you can do all this while actually improving efficiency and being more sustainable. It's a total game changer.
Okay, so that's the bleeding edge of academic research. Super cool. But how is this stuff actually being used by professionals on real, massive projects today? Let's shift gears and look at how a top-tier firm, SHO Architects, is putting these exact ideas into practice. This quote right here, it just perfectly captures Shop's entire philosophy. They call it having an operational mindset. What it means is that the days of just being a designer and handing off a drawing are over. To really make digital fabrication work, you have to know, really know how things are made. You've got to understand the materials, the machines, and the processes to design for them effectively.
And this is what happens when you have that mindset. On the left, you see the incredibly detailed digital model for the Barclays Center in Brooklyn. Every single one of its 12,000 unique facade panels was designed digitally. And on the right, that's the finished product. The digital files were sent directly to the fabricator, resulting in a perfect one-to-one translation from the screen to steel. The level of precision needed for this is just mind-blowing.
And that right there is the key benefit. This is what it's all about. The technology literally closes the loop between what you design in the digital world and what gets built in the physical one. All the little errors and misinterpretations that happen when people try to read 2D drawings, they just vanish. What you see is what you get. But here's where it gets even cooler. It's not just a one-way street. We can actually feed the physical world back into the digital model. What you're looking at here is a LiDAR scan of a construction site. It's basically a super accurate 3D laser scan that creates a perfect digital twin of the as-built conditions. You can then lay that over your original plan to check for accuracy and spot problems in an instant. The information loop is complete.
So, we've seen the lab, and we've seen it in the field. Let's zoom out and talk about the big picture. Why does any of this really matter for the architecture, engineering, and construction industry? What kind of major changes are just around the corner?
Well, the impact is going to be massive. First off, the way teams collaborate is going to completely change because everyone will be working from the exact same data. Second, get used to seeing robots on site. Man-machine interaction is going to become the new normal. Third, this tech allows us to optimize materials and slash waste, paving the way for way more sustainable building. And finally, it's the rocket fuel for industrialized construction, making parts in a factory and just assembling them on site.
Look, at the end of the day, here's the biggest takeaway. Digital fabrication isn't some quirky, futuristic experiment anymore. It's here. Whether you're an architect, an engineer, a project manager, or a builder, understanding this stuff is becoming an absolutely essential part of your job. It's the new language of construction.
And that leaves us with one last, really exciting thought. As the messy, unpredictable job site slowly transforms into a precise, data-driven assembly line, all the old rules about what's possible in construction are starting to fade away. So the real question isn't just what's next for the industry, it's what's next for you. In this new world, what are you going to build? Thanks for joining us.